Hello students, welcome to Educate. Now in the last class we have discussed about the expressing concentration of solution and we have discussed some numericals. There is some unsolved numericals and I have told you to solve these questions. I hope majority of students have solved this question. Even though I give you some hint to how to solve this question. Okay, let's go. Calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Okay, mass percentage of benzene here, benzene it is here. So benzene is solute, carbon tetrachloride solvent. 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Hope very easy. Everyone have solved this question. Even though I hint you here, benzene mass is 22 gram and carbon tetrachloride is 122 gram. So total mass of solution will be how much? 22 gram plus 122 gram, that means 144 gram. Here total mass of the solution is 144 gram. You have to find out mass percentage of benzene. So mass percentage of benzene, that will be equal to 22 gram upon 144 gram into 100. Gram cancel out. After solving, what will be? That will be your answer. Okay? Was that question not easy? Now proceed. The next question. Calculate mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. About that we will have to discuss. Let's see. Mole fraction of benzene you will have to find out, and mass of their percentage of benzene has been given 33. That means here if total mass of solution will be 100 gram, then mass of benzene will be 30 gram. So here if total mass of solution will be 100 gram, then mass of benzene equal to 30 gram. That is the meaning of mass percentage. If total mass of solution will be 100 gram, then mass of benzene will be 30 gram, and that of carbon tetrachloride is the solvent. So mass of solvent will be 70 gram. It's asking mole fraction of benzene. So number of moles of benzene you will have to find out, and number of moles of carbon tetrachloride. So number of moles of benzene, that will be here 30 gram, that upon molecular weight of benzene. What will be the molecular weight of benzene? C6H6. So 12 into 6 plus 6 into 1, 72 plus 6, that is 78. So that will be, say, 30 gram upon 78 gram per mole. Gram will cancel out. Mole will go in the numerator. That will become mole. So that will be 30 upon 78. That much mole. So number of moles of benzene calculated. Now number of moles of carbon tetrachloride you will have to find out. So number of moles of CCl4. Weight of CCl4 is 70 gram because 30 gram out of 100 gram solution, 30 gram is benzene. So carbon tetrachloride will be 70 gram. So that will be 70 gram. That upon here molecular weight of CCl4 will be how much? 12 for carbon plus 35.5 into 4. That is 12 plus 5 4 20, carry 2, 5 4 20 and 2, 22, carry 2, 5 4 3 12 and 2, 14. So 142 plus 12, 154. So 154 gram per mole. So gram will cancel out. That will be 70 upon 154 mole. Now number of moles of benzene when you will have to find out. So that will be equal to number of moles of benzene upon number of moles of benzene plus number of moles of carbon tetrachloride. Because number of in the solution there will be particle of benzene and that of carbon tetrachloride. So same here, very simple. Number of moles of benzene you have calculated here 30 upon 78. 30 upon 78, that much mole. That upon 30 upon 78, that much mole plus. It is 70 upon 154. 70 upon 154 mole. Okay, you solve this question, that will be the answer. Okay guys, now proceed on the next topic. That is here 1.3. Let's see 1.3. How to solve? Question is, calculate molarity of each of the following solution. 30 gram of A, 30 gram of this one in 4.3 liter of solution. C is 30 milliliter of this much H2SO4 diluted to that much. Let's see how to solve this question. So now, what is here? 30 gram of CONH3 whole twice, that is in 4.3. So molarity you will have to find out. Molarity, what is a molarity? Number of moles of solute present in 1 liter of solution. Molarity is number of moles of solute upon volume of solution in liter. That is molarity. So let's see. Molarity of, you have to find out 30 gram of cobalt nitrate dissolved in 4.3 liter of solution. B, 30 milliliter of 0.5 molar H2SO4 diluted to 500 milliliter. This question you will have to do. Next question. This question you solve by yourself. Very easy question. And here this question and this question is similar. So we are discussing on this question. 1.4. 1.3 is very simple question. Now let's see 1.4. Calculate the mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. Let's see. So 0.25 molar solution it is. Molality of solution is, you know, number of moles of solute upon volume of solution in liter. Volume of solution in liter. So molality is given 0.25. Oh, sorry, here not volume, here mass. Here will be mass of solvent in kg. Mass of solvent, not solution, solvent. Mass of, because it's molality, not molarity. So that will be that upon mass of solvent in kg. Okay, here Mass of solvent is 2.5 kg. 2.5 kg mass of urea. Mass of urea is 2.5 kg here. So molality is here 0.25. So 0.25, that will be equal to number of moles of urea. Mass of this one is 22.5 kg. It is 0.25 mole, 0.25 mole per kg into 2.5 kg. That will be equal to number of moles of urea. So 0.25 and 2.5, 625 kg cancel out. 625, 0.625, that will be equal to number of moles of urea. Its mass you will have to find out. Number of moles you have calculated. Here number of moles you have calculated, that much mole. So mass given that means their number of moles into molecular weight. So mass of urea, that will be equal to 0.625 mole into molecular weight of urea. Urea here 14 plus 2 plus 12 plus 16 plus 14 plus 2. So this one, this into 60, that will be that much in gram, because it is mole and molecular weight will be 60 gram per mole. So mole will cancel out. So answer which you got, that will be in gram. Okay guys, let's see. Calculate molality and mole fraction of Ki if the density of 20% aqueous Ki is this much. Solve this question, and this question is very easy. If these two questions I have solved, if you have understood these two questions, then very easily you can solve this question and this question also. Okay, now let's see. Proceeds on the next chapter. Let's see. Next one is solubility. So let's see about solubility. How to do solubility. So solubility is what? What is solubility? Listen, solubility is the maximum amount of solute which can be dissolved in a given amount of solvent. Solubility is the maximum amount of solute which can be dissolved in a given amount of solvent. That is called solubility. And what is saturated solution? Hope you know saturated and solution. That means if a solution cannot dissolve further, if in a solution further a solute cannot be dissolved, then that solution is called saturated solution. That means if in a solvent how much solute can be dissolved, if that much solute has already dissolved, then that solution will be called saturated solution. Okay, that is solubility. Let's proceed the next topic, that is solubility of solid in a liquid. Solubility of solid in a liquid, this one. Everyone know like dissolves like. Every student is aware about this slogan, like dissolves like. But what is actually its meaning? When you would like to dissolve a solid in a liquid, then there is a concept that like dissolves like. It means that when a polar solute can dissolve in a polar solvent only, and a non-polar solute can be dissolved in a non-polar solvent only. As for example, in water, you can dissolve NaCl. Why NaCl is soluble in water? Because NaCl is an ionic compound, and ionic bonding is the extreme case of polarity. Ionic bonding is the extreme case of polarity, and water is also a polar compound. Water is also a polar compound, and NaCl is an extremely polar compound. So NaCl could dissolve in water. Another compound we are aware in our day-to-day life, that is naphthalene ball. Naphthalene ball in public toilets, you might have washed the naphthalene balls that's used as an disinfectant. Naphthalene ball that is of white color, and naphthalene ball is also used to preserve the clothes. That means in the clothes, naphthalene balls kept and stored in the almirah or any other wherever you want. So naphthalene ball will prevent the action of microbes or other microorganism which will affect your clothes. So naphthalene ball that will be soluble in organic solvent. So that means like dissolves like means a polar solute will be soluble in a polar solvent, and a non-polar solute will be soluble in a non-polar solvent. That is the meaning of like dissolves like. Now that is here, and solute solvent you know already here. So solvent will be the liquid and solute will be solid. That will be the solution here. Now next point here is, next point what will be, that is here effect of temperature. That means what will be the effect of temperature on the solubility of solid in a liquid. The effect, what will be the effect of temperature on the solubility of solid in a liquid. Keep in the mind, I think you have watched about the chasni in which the jalebi or laddu, bundi, that is, or other different types of sweets are used to make. That is chasni. What is here? How the chasni forms? Water got heated, and in that water got heated, and in that water sugar kept. Water got heated. So on increasing the temperature, more and more amount of sugar could dissolve. When the temperature of water has been increased, then the amount of sugar which can be dissolved in a liquid, that will increase. So here the solubilization of sugar in water is an endothermic process. The solubilization of sugar in water is an endothermic process. That's why on increasing the temperature, more and more amount of sugar was dissolved. So And what is the endothermic process? That means the process in which there will be absorption of heat. That will be called endothermic process and exothermic process. Endothermic process is the process in which there will be requirement of temperature and there will be requirement of heat energy. So obviously temperature will have to rise. So here solubilization of sugar in water is an endothermic process. Solubilization of sugar in water is an endothermic process. That's why on increasing the temperature, the solubility of sugar in water has increased. Next case, here water is here and you dissolve limestone, CaCO3. Might you have seen the process of whitewashing. During whitewashing, what the artist do? He keep the CaCO3 limestone in water. And you might have observed that the boiling of water started when calcium carbonate, that means limestone, kept added in the water, then water will start boil. What is here? Because temperature has here increased. So solubilization of limestone in water is an exothermic process. Exothermic process. So what happened? If CaCO3 could dissolve in cold water more easily than that of hot water. Here sugar could dissolve in warm water more easily compared to that of cold water, and the calcium carbonate could dissolve in cold water more easily than that of hot water. What is here actually? What is here? Sugar here. Sugar you are adding in water, and so during that process heat energy required. So sugar comes in aqueous state. Aqueous state means it got dissolved. So for to solubilize the sugar, there will be requirement of heat energy, and if you will supply the heat energy, so obviously this process will take place. That's why if solubilization will be an exothermic process, if in case of CaCO3, if solubilization, and listen here this one also, when CaCO3 you try to dissolve in water, so during that course CaCO3 got dissolved, so that it will comes in aqueous state and heat energy will evolve. So if you will supply the heat energy to CaCO3, that means here aqueous CaCO3, then precipitation will take place. So at greater temperature, less amount of calcium carbonate will dissolve, and at lower temperature, more amount of calcium carbonate will dissolve. Here solubilization of sugar in water is an endothermic process. It needs heat, and you are supplying the heat energy, so solubilization will increase. So that means if solubilization will be endothermic. Endothermic means that require heat energy. So if solubilization will be endothermic, then on increasing the temperature, solubilization will increase. And some here is, that means if solubilization will be an endothermic process, then if you will increase the temperature, solubilization will increase. And if solubilization will be exothermic process on the place of endothermic, if that will be exothermic, then on increase the temperature, solubility will decrease. Okay, that is the meaning of here. And this principle is called Le-Chatelier's principle. Le-Chatelier's principle has been applied here to imagine that on increasing the temperature, the solubility of a solid in a liquid will increase or decrease. So how we will predict? If solubilization will be an endothermic process, then on increasing the temperature, the solubility of solid in liquid will increase. While if solubilization will be an exothermic process, then on increasing the temperature, the solubility of solid in liquid will decrease. Okay guys, that was about Le-Chatelier's principle. So we have studied about the solubility of solid in a liquid. The solubility of solid in a liquid on increasing the temperature by Le-Chatelier's principle. Now, effect of temperature. What actually is effect of temperature here? Effect of pressure. Suppose here this is a glass here. You dissolve sugar and this vessel is closed. Will there be any pressure on this wall? Obviously no. So solid and liquid do not exert the pressure on the wall of container. So there will be no appreciable change in solubility of solid in liquid on increasing the pressure. So when a solid will dissolve in a liquid, then there will be no any effect on the solubility of solid in liquid on increasing or decreasing the pressure, because solids and liquids do not exert pressure on the wall of container. There will be pressure only due to force of gravity. Okay, so that was about effect of temperature and effect of pressure. Okay guys, now we will discuss about solubility of gas in a liquid. The solubility of gas in a liquid, we will discuss about that. What actually is the solubility of gas in a liquid? About the solubility of gas in a liquid, we study by Henry's law. About the solubility of gas in a liquid, Henry's law informs that the solubility will increase or decrease. About the solubility of gas in a liquid, we study by Henry's law. What Henry's law states? Listen here. Suppose there is two containers here. One container here, this container, water is here, and you are dissolving, in first case, oxygen. Here partial pressure of oxygen is suppose 2 atm, and there is another container, and here in this one is also solvent is water and oxygen is getting dissolved. Partial pressure of oxygen is 3 atm. So here partial pressure is 2 atm and here partial pressure is 3 atm. So here oxygen will dissolve more. So Henry's law states that the solubility of gas in a liquid. Henry's law states that the solubility of gas in a liquid will increase on increasing the partial pressure of that gas. What is partial pressure? Partial pressure is the pressure exerted by the gas in a liquid. Partial pressure is the pressure exerted by a particular gas at the surface of the liquid, that is partial pressure. If suppose here oxygen is also exerting the pressure, nitrogen is also exerting the pressure, and suppose its partial pressure is 5 atm. So pressure exerted by oxygen is 2 atm. So partial pressure of oxygen is 2 atm, and the pressure exerted by nitrogen is 5 atm. So partial pressure of nitrogen will be 5 atm. Total pressure of the gas will be 2 plus 5, that means 7 atm. That is partial pressure. So Henry's law states that the solubility of gas in a liquid will increase on increasing the partial pressure of that gas. Here already in the books and NCERT books that has been also written, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. That is Henry's law. Obviously, the solubility of Henry's law states that the solubility of gas in a liquid will be directly proportional to partial pressure of that gas over the liquid. And when we will have to express in mathematics form, then there is a direct relationship between the mole fraction of gas inside the liquid and the partial pressure of that gas. You have studied a number of expressions to express the concentration of the solution. Here, molarity, molality, mole fraction, ppm, mass percentage, so on are the expression used to express the concentration. If concentration is more, that means more amount of solute is present in a given amount of solvent. If concentration is more, so if concentration will be more, so every value will be more. Every values, that is molarity will be more, molality will be more, mole fraction will be more, and so on. Here the direct relationship is between partial pressure of gas and the mole fraction. So Henry's law states that the partial pressure of gas will be directly proportional to mole fraction of that gas in the solution. Partial pressure of any gas will be directly proportional to mole fraction of that gas in the solution. So if you have to remove this proportionality sign, then you will have to keep a constant, and that constant I have taken, and it has been taken Kh. That is called Henry's constant. This Kh is called Henry's constant. In NEET examination, there is a priority of asking the question, what is the unit of Henry's constant? What is the unit of Henry's constant? Listen, partial pressure here gas. So pressure is, its unit will be atm or bar or whatever you want to write. That is Pascal, whatever you would like to write. Mole fraction has unit, no unit. So unit of partial pressure will be same as that of Henry's constant. So Henry's constant, unit of Henry's constant will be atm or bar or Pascal or any other term. So unit of Henry's constant will be same as that of pressure. Okay, so that was here. Now suppose here a liquid is here. In this liquid, a particular gas has been tried to dissolve. Firstly, suppose its pressure is in terms of torr. So if pressure has been increased, then mole fraction of that gas. If pressure will increase, then mole fraction of gas inside the liquid will increase. There is a direct relationship between mole fraction of the gas and the partial pressure of the gas. That is, as the partial pressure of gas will increase, like that, in the same manner, the mole fraction of gas inside the solution will increase. So that's why there is a straight graph between the partial pressure of gas and the mole fraction of gas. Okay, let's see here. That was about Henry's law. Usually in the 12th board examination, question asks, states Henry's law, and that is of 2 marks. How you will have to write to get 2 marks? First of all, you will have to write the what is actually the Henry's law states. That means the solubility of gas in a liquid is directly proportional to partial pressure of that gas inside the liquid. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. That is, and then after you will have to write this expression which has been given here, and it is must P equal to KH chi. That you will have to write. When you will write this 2 statement, then you will get 2 marks. Okay guys, to get 2 marks out of 2, you will have to write the statement of Henry's law and this expression, both. Now let's see to solve next type question here is, and how to solve this question. This question frequently asked in 12th board examination in 2 marks. This numerical question asks frequently in 12th board examination, and that kind of questions will be of 2 marks. Let's see how to solve this question. Read the question carefully firstly. Let's see. Nitrogen gas bubble through water at this much Kelvin. How many millimoles of nitrogen gas would dissolve in 1 liter of water? Assuming that nitrogen exerts a partial pressure of this one, and Henry's law constant is given 76.48 kilobar. Okay, so let's see here. What is here? It is asking how much millimoles of nitrogen will be present in the solution. Here it is 1 liter water and partial pressure of nitrogen is 0.987 bar. That means what the only pressure exerted by the nitrogen is 0.987 bar, and the volume of solution is 1 liter, and it is asking number of moles of nitrogen in terms of millimoles will be how much. So let's see, you know already by Henry's law constant, partial pressure of nitrogen, that will be equal to KH into mole fraction of nitrogen inside the solution. Partial pressure of nitrogen is 0.987 bar. KH is given here 76.48 kilobar. So 76.48 into 10 power 3. That much bar into mole fraction of nitrogen here. And how to find mole fraction of nitrogen? Let's see here. how to find mole fraction of nitrogen. So that will be equal to number of moles of nitrogen upon number of moles of nitrogen plus number of moles of water. So water. Mole fraction of nitrogen will be equal to number of moles of nitrogen that upon number of moles of all the component present in the solution. Here there is two component in the solution, that is nitrogen and the water. So that's why mole fraction of nitrogen will be equal to number of moles of nitrogen upon number of moles of nitrogen plus number of moles of water. Nitrogen here you have to find out, and mole fraction of nitrogen here you can also find out. So mole fraction of nitrogen, that will be equal to mole fraction of nitrogen, that will be equal to 0.987 bar, that upon 76.48 into 10 power 3. That much bar will cancel out. So mole fraction of nitrogen, that you can find out, and after calculation that will come 1.29 into 10 raised power minus 5. So watch out, mole fraction of nitrogen is very less. 10 raised power minus 5 in terms of 10 raised to power minus 5. That means very less amount of nitrogen will be present in water. The mole fraction of nitrogen is very less. That means very less amount of nitrogen could dissolve in water. So here during the addition, this one, so in addition number of moles of nitrogen plus number of moles of water, that means very less amount of nitrogen will be present in water, means when you will add the number of moles of water plus number of moles of nitrogen, that will be equal to number of moles of water, because this value is very less, this value is very less. So very large quantity plus less quantity, that will be that quantity. So that's why since mole fraction of nitrogen, that is very small, so number of moles of nitrogen plus number of moles of water, that will be nearly equal to number of moles of water. So mole fraction of nitrogen, that will be equal to number of moles of nitrogen upon number of moles of water. Number of moles of nitrogen you will have to find out. Mole fraction of nitrogen you have calculated 1.29 into 10 power minus 5. That will be equal to number of moles of nitrogen, that upon, let's say how to calculate number of moles of water. There is 1 liter water. 1 liter water means, or 1 kg water. 1 liter water means 1 kg water, because the density of water is 1 kg per liter. The density of water is 1 kg per liter. That's why 1 liter water means 1 kg water, and that means there will be 1000 gram water. So number of moles of water will be number of moles of water, that will be equal to 1000 gram upon 18. When you will divide this one, that will be 55.55. So number of moles of nitrogen, that upon 1000 upon 18, that is 55.55. So number of moles of nitrogen will be equal to 1.29 into 10 power minus 5 into 55.55. That much. Okay. So that's after multiplying them, that will be 7.16 into 10 power minus 4. That much mole. It is here also mole, because that is gram and it is gram per mole. Gram will cancel out, so mole will come in the numerator, and that becomes mole. Mole inverse will come in the numerator and that become mole. So 7.16 into 10 power minus 4 mole. This one, and in terms of millimole you have to find out. So you will have to multiply by 10 to the power 3. That much millimole. So that means 0.716 millimole. 0.716. Why here millimole to mole? Because when you will have to convert mole into millimole, like 1 kg into 1000, when you will have to convert 1 kilogram into gram, you will have to multiply by 1000, because kilogram is a larger unit and gram is a smaller unit, and you will have to convert a larger unit into a smaller unit, so you will have to multiply. In the same way, here you have to convert mole into millimole. So here mole is a larger unit and millimole is a smaller unit. That's why to convert mole into millimole, you will have to multiply by 10 raised to the power 3. Okay guys, this question frequently asked in 12th board examination. I hope this one is, you felt easy. Now what is here? Application of Henry's law. Very easy. Application of Henry's law. And that's also asked in 1 marks question in 12th board examination. And in IIT main, in NEET examination that's asked sometimes, but in IIT main and advanced, question don't ask. Frankly speaking, question don't ask in IIT main or advanced. In this one, application of Henry's law. But rarely from this topic the question asked in NEET examination. But in 12th board examination, this question asked in 1 marks. One application is that, since one application of this Henry's law is that, since the solubility of gas in a liquid increases on increasing the pressure, that's why CO2 fills in the soft drink at high pressure. In soft drink, the CO2 gas fills at high pressure. One is that. Second one is in a scuba divert. Scuba divers means who goes inside the sea or river or any large lake like that. Scuba divert was when going inside and will coming back, then they were experiencing symptoms that is called bent. The scuba divert, when coming out from the surface of, coming out from the water source, then they were feeling symptoms which is called bent, B-E-N-T, bent. What are the symptoms of that bent? What was actually? Because inside the source of water, the pressure is more, so nitrogen gas were also dissolving in the blood of scuba divers. So nitrogen gas was also dissolving, and when he comes out from the water source, then nitrogen gas tends to escape out from his body, and that's why they were feeling nausea, vomiting, vomiting, and sometimes bleeding from nose. That symptoms was called bent. To avoid the symptoms of bent, nowadays inert gases fills in the oxygen cylinder used by scuba divert. So by filling the inert gas, the partial pressure of nitrogen will decrease, and hence when the scuba diver will be inside the water, even though only meager amount of nitrogen could dissolve in the blood of scuba diver, and hence he will not feel the symptoms of bent. Okay. Next point here, that was the persons living at high altitude. The person living at high altitude, they were experiencing symptoms called, the person living at high altitude were experiencing symptoms that is called anoxia. What is the symptoms of anoxia? The symptoms of anoxia is physical and mental weakness. And what is cause? Because the persons living at high altitude, that means hilly persons particularly, there at high altitude or at hills or mountains, the total pressure is less. So partial pressure of oxygen will be also less. So the persons living at high altitude will get less amount of oxygen during the breathing, and hence the ample amount of oxygen will be not available for the persons living at high altitude. Hence they be physically and mentally weak. Now, effect of temperature, what is that? Effect of temperature. If temperature will increase, then gases will tends to escape out from the solution. So when the temperature of the solution will increase, then the gases will tends to escape out from the solution. So on increasing the temperature, the solubility of gas in a liquid will decrease. Okay. In the next class, we will discuss about this, how to solve these two questions. And these two questions is very easy. When you will try to solve this question, you will realize that these questions is so much easy that you will not feel the guidance of mind, even though I shall hint you in the next class. Today it's all for this class. Thank you, Team Educate.